Hello, this is Shivansh Rahangdale. This video is a part of my college assignment. I'm gonna explain the solution of some problems related to information security. So the first question is, how can multi-factor authentication methods increase the security of authentication compared to single factor methods? So what happens in multi-factor authentication is it adds an additional layer of security. It uses more than one factors to verify the user. Uh, it makes it more difficult for the attackers to gain unauthorized access. So here are some of the ways in which multi-factor authentication can increase the security. First one is reduce reliance on password. Second one is protection against phishing attacks, increased difficulty for attacker, compliance with regulations. So that's how multi-factor authentication has increased a lot of security for authenticating while when we compare it to single factor method. Now, what are some advantages and disadvantages of using biometrics for authentication compared to other methods such as passwords or smart cards? So when we talk about its advantages, there are stronger authentication. It provides convenience, it increases security, and they are scalable. And the disadvantages are they are very their cost is we have to pay some money. One means there first factor is cost, second factor is privacy concerns, third is accuracy. Sometimes they are not accurate while scanning the data. The fourth one is lack of standardization. How do authentication methods such as public key cryptography protect against attacks such as man in the middle attack and replay attack? So when we talk about man in the middle attack, what happens is an attacker intercepts communication between two parties, typically by impersonating one of them. Public key cryptography can protect against man in the middle attack by using digital signatures to ensure the authenticity of messages. When a message is sent, it is signed with the sender's private key, which can only be decrypted using the corresponding public key. If the message is intercepted and modified by an attacker, the digital signature will no longer match, and the receiver will know that the message has been tampered with. Now, for the replay attack, in a replay attack, an attacker intercepts a message and replays it later in an attempt to gain unauthorized access. Public key cryptography can protect against replay attacks by using a nonce, which is a random number generated by the sender for each message. The nonce is included in the digital signature, and the receiver checks that it has not seen the same nonce before. If the nonce has already been used, the receiver knows that the message is a replay and rejects it. In what ways can biometric authentication methods be vulnerable to attacks such as spoofing or replay attacks? And what measures can be taken to mitigate this risk? So the first one is spoofing attack. Biometric authentication can be vulnerable to spoofing attack if the bottom biometric sensor is fooled by a fake biometric characteristics such as a silicon replica or of a fingerprint or a 3D printed face. To mitigate these risks, organizations should use biometric sensors that are resistant to spoofing. Now, as for the replay attack, biometric authentication can be vulnerable to replay attacks if the biometric data is not securely transmitted or stored. If we talk about the data breaches, biometric data breach can occur when an attacker gains unauthorized access to a database containing biometric data. In order to mitigate this risk, biometric data should be stored securely using strong encryption and access controls. Additionally, organizations should implement measures to detect and respond to data breaches quickly, such as monitoring user activity and implementing multi-factor authentication. What are some potential drawbacks of relying on hardware-based trusted computing solutions such as TPMs or secure enclaves? Potential drawbacks to relying on this solution including the complexity, limited portability, risk of vendor lock, potential for hardware performance impact. So it increases the complexity, it has limited portability, it in some trusted computing solution may be proprietary, which can lead to vendor lock-in and reduce flexibility. This can limit an organization's ability to adopt new technology or switch vendors in the future. If we talk about the potential on hardware-based attacks, while hardware-based trusted computing solutions provide a high level of security, they are not immune to attacks. So, hardware level vulnerabilities such as side channel attacks or hardware trojans can be exploited to bypass security mechanism and compromise sensitive data. If we talk on now, the last point is performance impact. Hardware-based trusted computing solution can have a performance impact on systems, especially if they are used extensively. This can be a concern for applications that require high performance computing on real life processors. How can trusted computing technologies such as secure boot and core signing be used to prevent malware and other attacks on computer systems? Here are some ways in which trusted computing technologies can be used to prevent malware and other attacks. This includes secure boot, code signing, trusted platform module, remote attestation. Now, how can side channel attacks be used to extract information from systems that are designed to be secure, such as encrypted communications or hardware security modules? Side channel attacks can be used to extract information from systems that are designed to be secure, such as encrypted communication or hardware security modules, by exploiting the information leaked by the system's physical properties. Here are some examples which can be used to extract information. First one is power analysis attack. It analyzes the power involving monitors the power consumption of a system to extract sensitive information. Second one is timing attacks. It involves measuring the time it takes for a system to perform certain operation. Third one is electromagnetic attacks. EM attacks involve monitoring the electromagnetic radiation emitted by a system to extract sensitive information. And the fourth one is acoustic attack. Acoustic attack involves measuring the sound generated by a system to extract system information. So these were about the side channel attacks. Now, how can countermeasures such as power analysis, resistant design, or randomization be used to mitigate side channel attacks? And what are the trade-offs between security, cost, and performance? Side channel attacks are attacks that exploit information leaked by a system's physical properties such as power consumption, electromagnetic radiation, or timing. Countermeasures such as power analysis, resistant design, and randomization can be used to mitigate side channel attacks. So, the first one is power analysis resistant. The first countermeasure is power analysis resistant design. Power analysis power analysis attack involve monitoring the power consumption of a system to extract cryptographic key. Now, what we can do is power analysis resistant design can be used to mitigate this attack by minimizing the amount of power consumed by cryptographic operation. What it does is it minimizes the amount of power consumed by the cryptographic operations. So this can be achieved through techniques such as voltage scaling, power gating, and current limiting. So this is about the power analysis resistant design. Second one is randomization. Randomization can be used to mitigate side channel attacks by introducing random variation in system behavior. making it more difficult for attack to extract useful information from side channel attacks. Randomization can be achieved through techniques such as random delays, randomizing algorithm behavior, or randomizing the order of operations. Uh, so now the third countermeasure that we can take is trade-offs. The trade-offs between security, cost, and performance must be carefully balanced when implementing countermeasures for side channel attacks. Stronger countermeasures often come with higher cost and performance impacts, while weaker countermeasures may not provide sufficient protection against advanced attacks. In addition, countermeasures that are effective against one type of side channel attacks may not be effective against others, requiring a multi-layered approach to side channel attack mitigation. So these were the countermeasures uh, for in order to mitigate the side channel attacks. So that's it for the solution. Thank you for watching.